Okay, so today we are going to be looking at the three forms of a quadratic equation and why we have three different forms of a quadratic equation. So you guys may remember this picture. We've seen it a couple times. And it has a picture of a parabola, which is our graph of a quadratic equation. And we have the three different forms that we might see them in. So we have the standard form, the vertex form, which is our new form this week, and also the factored form. What you may notice, and I'm going to point this out before we get started, is that each one of these out in front of the x squared has this a. Okay, and that a tells us a lot of information before we even start. So if a is positive, what that tells us about our graph is that our parabola will open up or be concave up. Sometimes you'll hear that. I also think it looks kind of like a smiley face. So it's a positive, happy parabola. It is going to be opening upwards with your arrows going in that direction. If that a value in any form is negative, so that number out in front of your x squared, that coefficient is negative, what that does is give you an upside down parabola, so like a frowny face parabola. In other words, it's concave down. So, if it's a little bit more mathy, that's what it will say. But each one of these forms tells us some other information as well. So for instance, in the standard form, y equals ax squared plus bx plus c, you may or may not remember from last week that this c is really important. This c tells us our y-intercept. Okay, and what a y-intercept is, again, that's where our graph crosses the y-axis. Okay, so that's your y-intercept. So that's pretty important. It's one of the pieces of the puzzle. The vertex form, that's the one that we've been looking at this week. Vertex form gives you a little bit of information. Of course, it tells you what your vertex is. Vertex is just another name for turning point. Okay, and that comes straight out of the equation. So this form will be y equals a times x minus h squared plus k. And what you may remember from the previous video about vertex form is that the x always lies. So whatever's next to that x, whether it's a positive, like a plus something, well, that's going to really mean a negative. It's a minus something like here, that really means it's a positive. So it would be h comma k. Whatever's added or subtracted at the end, that's going to stay the same. The other thing that the vertex form can help us easily find, and it's not on this picture, so I'm going to draw it in, is the axis of symmetry, which should be a straight vertical line that cuts your parabola in half. Mine's a little bit wonky, but that's just my writing program here. So it helps us also find the axis of symmetry, which we looked at that another way last week as well. So the axis of symmetry, or I'm going to abbreviate here, AOS, for an equation in vertex form is going to be x equals, since it's a vertical line, and whatever that x coordinate of your vertex is. So x equals h. And finally, this last form, the factored form, which I know we looked at this week. I'm just trying to change colors here. There we go. These are in orange. We have a times x minus p times x minus q. These tell us our x-intercepts, so where our graphs cross the x-axis. What we also have to be aware of is that they have some other names. You might see them referred to as roots or zeros, okay, but all the same. This is where that zero product law comes in, okay, that anything times zero would have to equal zero. So we could find these where our x-intercepts are by setting each one of these factors equal to zero and then solving them. So we would, if minus p, we'd have to add p to both sides. X equals, well, 0 plus p, well, 0 plus anything will keep the identity the same. So one of my x-intercepts would be equal to p, And the other one, if I add q to the other side, my other x-intercept would equal q. And that's the other thing that we did this week. We just use those with numbers. Okay, so on this next slide, these should look familiar to you. Do you remember these? These are the warm-up sets of equations that we started looking at the beginning of the week. We have set 1 and set 2, and I love reading through your responses for these. Okay, a lot of people noticed when they were dealing with this is that we have lots and lots of letters for these. We have function rules in set 1 of f of x, g of x, h of x. We've got p of x, q of x, r of x. And the only reason that they did that is that way if someone is talking about one of these equations, you know exactly which one they're talking about. If these were all called y, it would be really hard to tell which one is which. So if I wanted to make an observation or talk about, say, like q of x, everyone would know which equation I'm talking about. So that's why they called them all these different letters. But it probably looks like a lot when you're looking at those. A couple other people noticed that we have a bunch of squareds in here. All of our equations have x's. There's no other variables. I did hear about factored form is part of this. Hopefully, if you're looking at this again now after doing some of the assignments from this week, you also notice that we have vertex form on here as well. Some of the wonders that I saw where I wonder what we're going to do with these. I wonder what this all means. I wonder if these are all the same equations. And those are all great things to notice. So our wonder about that, if I separate these two so you can see them, set 1 is all the same equation. It's just written in 3 different ways. So and I can kind of see this quickly with this one. If I were to multiply this together and distribute, x times x would give me x squared. X times 4 gives me 4x. So I could see that these two are the same. This one takes a little bit more work. I'd have to do the box and multiply that all out and subtract 4, but that would also be the same thing. So these are all the same equations, and these are all the same equations. They're just written in the different forms. The other thing here that some people noticed, more specifically about set 2, but here I'm going to point out that A is positive, that there's no negatives in front of those x squareds, meaning our parabola would open up. And here we've got some negatives that you can clearly see in the first and the last equation. Here it's a little bit hidden, but there is a negative in front of that x. Okay, which when we distribute that, it would make it a negative x squared. So here A is negative. So that would mean that we're opening down. So these forms, the top one for each of these, this first one, that's your standard form. So what we're used to seeing from our polynomial unit. Okay, that y equals ax squared plus bx plus c. Here, since they're written like a multiplication problem, this is our factored form. And then last but not least, down at the bottom, these are written in that new form where we have the parentheses and the squared, and then something added or subtracted at the end. So these ones are your vertex form. Okay, so I want to look at what information this tells us and how we can use that to get an idea about this graph. So we're going to look at set 1. Okay, so set 1, what do we know? Okay, so if we look at this right off the bat, based on your observations that you said before, one thing that we know already is that A is positive. So we know that our parabola, if we were to draw this, is going to open up. And as you guys can clearly see, we've got a grid there. We are going to be drawing this. Well, what else do we know? Right now, we know that there are 3 different forms of this problem, and we're going to use those to help us figure things out. So I'm going to start with this top one. So this is written in standard form. where it's written like a polynomial. And standard form is going to help us figure out our y-intercept. So where this graph crosses the y-axis. So our y-intercept on an equation that's in standard form is always the constant term. It's what gets added or subtracted after the x's. So for this one, there's no number there. So we have to remember that when there's no number written in, that really there's a +0 there. So that's telling us that our y-intercept is going to be at the point 0, or if you want to write it as a point, it would be 0, 0. Okay, so where our x is 0, our y is also 0. So if I were to go to my y-axis, which is not labeled here, so I'm going to take a second and do that. If I go to my y-axis, I would have my first point on this parabola right there at 0, 0. Clearly, 1 point is not enough to draw a sketch of a parabola. We're going to need a little bit more information. So that's going to bring us to the next part. This next equation is written like a multiplication problem. It's written like the distributive property, right? It's almost everyone's first instinct is to multiply that x into the parentheses. So this is our factored form. We don't have to multiply anything, okay? The factored form, though, that's going to help us find our x-intercepts or our zeros. I'm going to put that word in there. Okay, so our zeros. So this one takes a little bit of work. So I'm going to give myself some space down here. In order to find zeros, I'm going to set my equation instead of equal to g of x equal to 0. That's the only thing that's changed. So I have 0 equals x times x plus 4. And in order for one of these, in order for this product to equal 0, that tells me at least one of these factors has to equal 0. So either x has to equal 0 or x plus 4 has to equal 0. And then I solve these equations. I will need to find what x would give me 0. Well, when I look at this, x is equal to 0 is already done and solved for me. So that's it. I don't have to do anything else. Then on this one here, x plus 4 equals 0. Well, this one, I've got to undo my addition. So I'm going to subtract 4. And 0 minus 4 leaves me with negative 4. So that's telling me my two zeros, my two x-intercepts. And when we make a list like this in math, a lot of times we'll just use those fancy curly braces, and I can list out my two numbers. So if I wanted to do them that way, that's fine. If I wanted to write the points, or if they asked me for the coordinates of my zeros, that would be the point 0, 0. So both my x and y are 0, and my other one is the point -4, 0. So when my x is -4, my y is 0. So I have those 2 points I'm going to put on my graph. And I know I already have one on there. That's okay, because it crosses at the origin. Both the x and y intercept are the same there. Last but not least here, our new type of equation. We've got the vertex form. So the vertex form is going to help us find our vertex. Kind of crazy, right? It's right there in the name. You just need to recognize what one you're talking about. So in our vertex form, we're going to find our turning point or our vertex, and we need the x and the y coordinates. So the x coordinate is going to come from inside the parentheses right next to the x, but that x, that always lies. So since this says x plus 2, I know my vertex, my x coordinate needs to be -2. My y is always going to stay the same, so I'm going to do a -4. So now I have my turning point. I have that other point. So I'm going to go to the point -2, -1, 2, 3, 4. I'm going to plot my point. And I have 3 points right now. There are way more points on this parabola that I could draw and get, and I could do a whole bunch of math right now to get it. Or if I was in school, I could put this in my graphing calculator. I am not right now. So we're just doing a sketch of this. So we have these 3 points. I can see when I connect these that it should be going uphill and opening up. I'm going to try my best to draw them. It's not so bad. Okay, so I'm putting arrows on the end because this parabola does keep going on forever in that upward direction. I'm just not drawing all my points. The other thing I just want to draw your attention to is this parabola here, because it's opening upwards, it has a low point, okay? Or in other words, you might remember this from our functions, it has a minimum. Okay, so it has a minimum value or a low value. If we had a parabola that opened upside down, so a negative a, this one here, that would have a maximum value. Okay, so this hopefully started to make a little bit more sense of why it is that we have different forms of a parabola and how they can be useful depending on what information we may be looking for. You guys are going to be practicing some of this week in a pair deck. So we're going to try something a little bit different for us. You don't have to worry about drawing perfect graphs. Clearly mine is not perfect, but it gives you an idea of what's happening on that parabola. So we're going to be trying that out this week. But as always, guys, if you have questions on anything, please reach out to one of us. You can find us on Remind, leave us a message on the Google Classroom, or send us an email. So I hope that everyone is doing well, and I hope to see you guys soon, okay? We miss you. Bye.